Hello guys, today we're doing LeetCode question 733, flood fill. Now I've already done this question with the depth first search solution. Now I'm going to show you the breadth first search solution. So the question is, you're given an image represented by an n by n grid of integers image, where image ij represents the pixel value of the image. You are also given three integers, sr, sc, and color. Your task is to perform a flood fill on the image starting from the pixel image, starting row, starting column. To perform a flood fill, begin with the starting pixel and change its color to color. Perform the same process for each pixel that is directly adjacent, pixels that share a side with the original pixel either horizontally or vertically, and shares the same color as the starting pixel. Keep repeating this process by checking neighboring pixels of the updated pixels and modifying their color if it matches the original color of the starting pixel. The process stops when there are no more adjacent pixels of the original color to update. Return the modified image after performing the flood fill. So as you can see here, the image has got first row of 1s, second row 1 1 0, third row of 1 0 1. So the color of the starting position is a 1. So we have to change all adjacent ones to 2, which is the color they want us to set it to. So we set the same one to 2, the ones left and up 2. We don't set the bottom and right ones to 2 because they're 0, then don't match the same color as the starting one. Then from the left, we set the top and bottom to 2. From the top, we set the right to 2, and the 1 remains a 1 because it's not adjacent to any other ones. And now here they're all 0, so we just return 0. So the way we're going to do this is, as I've mentioned, we start from the position, check the adjacent elements if they're a 1. So we push that to a queue. While the queue is not empty, we set those to the color that we want to. Then we do the same for that position, etc. So I'll show you how to do this on the whiteboard first. So here we have our image. So let's say the starting row and starting column are both 1. So 1 and 1. First thing we do is we create a queue, and in that queue we put the starting position, so which will be 1 and 1. Then we create a start color as well, so we can always refer back to it when we need to check the value of the cell. So the start color will be 1. We'll put start here. Start is equal to 1. And now we check while the queue is not empty, we'll start to do the breadth first search. And before that, we have to set position array. So put position here. We'll hold each position. So the first position will be its own position, so it will be 0 0. And the second position will be to the right, which is 0 1. Then to the left, which is 0 minus 1. Then above, which is below, which is 0 1, and above, which is 0 minus 1. So that's the positions that we're going to refer. So in the queue, first we're going to get the starting position 1. For each column for each element in position, so now it's 0 0. We'll add it to the current position and check, because the current positions refer each adjacent position: the current, the right, the left, the bottom, and the top. So each adjacent position. So now at 1, we check, does that match the start color? Yes. Our color we're given, so color is 2, so we have to set it to 2. So now that value is a 2. Then we check the next position here, which is right. That's a 0, so we don't change it. Then we check the left. That's a 1, so we change that to 2 because it matches the starting color. So that's a 2 now. Then we check the bottom. That's a 0, we don't change it. We check the top. That's a 1, so we set it to 2. And then we push each one of them to queue. So I forgot to mention, so every time we check an element, we push to queue. So now in queue would be the first one will be the left value, which will be 1 0, and the second one would be the top value, which is 0 1. Now that we check the first value, we remove it from the queue. Then we go to the second value, 1 0. So now we're here. We check the left is out of bounds, so we don't check that. Then we check the bottom. We'll do the order doesn't really matter. Let's do the bottom for now. It's 1. So that is a 1, so we set it to 2. Push that in the queue. So now in the queue will be 2 0. Then we check the right. Right's already changed. We check the top. That's a 1. We set it to 2 as well. Just 2 here. And we push that to queue as well. So now 0, 0 is in the queue. 0, 0. And now that we've checked all values, we remove that position from the queue. 1, 0. Now we check the second position, the first position again. 0 and 1. So 0, 1 is here, top position. So we check top. Top is out of bounds, doesn't matter. Right? It's a 1, so we set that to 2. And we push that to the queue. So queue is now 0, and I've got 0 and 2. Then from there we check the bottom, that's already 2. We check the left, that's already 2. So remove that from queue and go to the next value. So now we're at 2, 0, which is the value here at the bottom. So the left value is out of bounds, we leave it. Bottom value is out of bounds, we leave it. The right value, 0, we don't touch it. Top value is already changed. So we finish the proof with that. Remove that from the queue. Now we're at 0, 0, which is the top left value here. Now we do the same for that. We check the left, it's out of bounds, top's out of bounds. Bottom's already changed, right's already changed. So we continue. Remove that from the queue. And finally, the last value is 0, 2, which is here. We check the top, out of bounds, right, out of bounds. And the bottom is a 0. We don't change it. The left is already changed. So remove from the queue. We finished. Now we'll return the image. So the returned image would be 2, 2, 2, 2, 2, 0, 2, 0, 1. And that's our result. Let me show you how to do this in code. So the first thing we do is we set our start value. So let's start is equal to position of the image, value of the position of the image of start row, start column. So that's our start color. Then we create a queue. So let queue is equal to first value, which would be start row, start column. If we don't put this in the queue straight away, then when we create the while loop to do the breadth first search, it won't work. Also, we check if the start color is equal to the current color, then we know we have to change it. So we just return the image as it is. Return image. As you can see here, it's the same color. Starting pixel is already colored with 0, which is the same as the target color. Therefore, no changes are made to the image. Okay. Now, the next thing we do is we'll start the breadth first search. So while queue dot length is bigger than 0, then we get the current position, the current value, the current position. So we'll get column and row is equal to queue dot shift. Then I forgot to mention we have to create our directions array. So const directions is equal to here. So our first one is the same position, 0, 0. Then we check the right position, 0, 1. Check the left position, 0, minus 1, minus 1. Check the top position, minus 1, 0. And the bottom position, 1, 0. Okay. Then we loop through each value. So for the direction, so for let column and row, let's do let row and column. This is the wrong order as well. Row first and column of directions. We do current column, so let or current row is equal to the row plus row. Do the same for the column, so let current column is equal to column plus C. Then we check that it's in bounds. So if the current row is bigger than or equal to 0, we know it's in bounds. If the current column is bigger than or equal to 0, we know it's in bounds. If the current row is smaller than the image dot length, then we know it's in bounds. And if the current column is smaller than image height, so image row dot length, then we know it's in bounds. And then it has to match the starting color, but only the starting color will change. So if the current position of the image, so image current row current column is equal to start, then we iterate through this. So first thing we do is we set the image position, so image current row current column to the color to change it, and then we push the current value that has been changed to the queue. So queue dot push position, which is current row and current column, and then we return the image. Let's run, see what passes. Current row, accidentally put if here. Let's run. That passes, as you can see. Let's submit. Perfect. As you can see, it beats most people for space complexity, but time complexity is a bit slow. Time complexity of this is OM of n, as worst case we loop through the whole matrix. The space complexity of this is also OM of n, as worst case through the whole matrix in the queue. Now I've already done the depth first search, which is much faster than this. I'm going to link in the description if you're interested in that. And thanks for watching.